Alright, question 1.9. The polynomial p of x has degree 3 and has p of 0 is 0, p of 1 is 1, and p of 2 is 2. The polynomial has a repeated root at x equals to m, with m is greater than 0. The value of m is how many? Okay, so it might be tempting to just set up a cubic, right? You could set up like ax cubed plus bx squared plus cx plus d, and then you sub in the information you have, and then you try to figure out the a, b, c, d's, right? But then the thing is, you have only 3 pieces of information, which is not very good, right? And even if you had 4, then solving simultaneous equations in 4 variables is not very pleasant either way. Okay, so maybe we've got to utilize the repeated root information. Yep, so maybe we could construct the cubic in terms of its roots. So where are its roots? Well, we know that 0 is a root because p of 0 is 0. Yep, so let me construct p of x. Well, then definitely x is a factor of that polynomial because 0 is a root. And the polynomial has a repeated root, very important, repeated root at x equals to m. So this bracket must be x minus m squared. Now, it can't be power 1 because it's repeated. It's squared. And it can't be a cube as well because the other root is at 0. Right? So there's no cube involved. So it must be a square. Okay, and remember, you could put a constant in front, an a, right? Because the ax cubed plus bx squared plus cx plus d. You could have an a in front. It stretches the graph, you know, up and down, but it doesn't really change where the roots are. Yeah, because the roots are on the x-axis. If you stretch it up and down, well, that changes your y-intercepts, but doesn't change your x-intercepts. Yeah? Okay, so then, now we just jam in our information. So 1 equals a times 1, and then times 1 minus m all squared. Same logic. 2 equals to a times 2, so 2a, and then 2 minus m all squared. Okay, how do we solve these? Now, I'm interested in m, right? I'm interested in m. I really don't care what a is, so I have to find some way to eliminate the a. What can I do? Well, let's clean up a bit first. The 2's cancel, and then I'm going to divide the equations. You know, what's nice about that? Well, the a's cancel. The a's cancel really nicely. Here. So 1 equals 1 minus m all squared over 2 minus m all squared. Alright, and from here it's just algebra. I don't really need to show you guys. Minus 4m plus m squared equals 1 minus 2m plus m squared. Just expansions, and nicely the m squareds cancel. Lovely. So 3 equals to 2m, and lastly m is 3 halves. So the answer would be E. There we go.